This is the washer method for question 1C. So the washer formula is pi the integral of a to b of the outside radius squared minus the inside radius squared times dx. Now, since we're dealing with it's going around a vertical revolution or axis of revolution, we have to put these terms into terms of x or y, so we can multiply by dy since our representative rectangle is sideways. So doing that, you just flip it, so y equals x cubed would now be x equals the cubed root of y, and we already have x equals 2 as our other thing, so we don't have to do anything else with that. We can just keep x equals 2. So now we want to find out the outside radius and the inside radius. This is the outside radius and this is the inside radius. So now to find those, it would just be, this is just 4 minus 2, because obviously we just need to find this, and 4 minus 2, that's equal to 2. So inside radius is just going to be 2. We could write that as 4 minus 2 anyway. I'm just going to keep that a to b for now. This outside radius you get from just it would be 4 minus the whole, wherever the x value ends up. So as the representative rectangle goes up and down, it follows this path, which makes the radius bigger or smaller. So the radius for that is just going to be 4 minus wherever x is, but remember that x is cubed, or y to the cubed root of y. So the outside radius is going to end up being 4 minus the cubed root of y minus the inside radius, that has to be squared, minus the inside radius, which is just 4 minus 2, that's also squared, times dy. So now you just have to solve out the integral, which shouldn't be that hard. When x equals 2, since that's where they're intersecting, obviously, because the line is x equals 2, you could just plug in 2 y, or 2 for x in that, and then that would give us y is equal to 2 to the third, which is equal to 8. So you know that the bounds are going to be from 0, because it starts down here, to 8 all the way up there. So we can go ahead and put those in 0 to 8. And then I'll simplify this a little bit more. So the cubed root of y, well, 4 squared is 16, and the cubed root of y squared, you could just think of the cubed root of y as y to the 1/3, and then y to the 1/3 squared is just y to the 2/3. So we could just write that as y to the 2/3, and then minus 2 squared, which is 4. That's all dy times by dy. So then you just take the integral of that, and that's going to end up being pi. The integral of 16 is 16y. We're doing everything in terms of y because we're multiplying by dy, minus the integral of y to the 2/3 is going to be 3 over 5 y to the 5/3, because you add 1 and then divide by that also, but since it's a fraction you reciprocate it and it equals the same thing, and then that minus by 4y, and then you could simplify the 16y and the 4y down to just 12y minus 3 over 5y to the 5/3. That's all evaluated at 0 to 8. And then you just apply the fundamental theorem of calculus again, which is just going to give you 12 times 8, that's 96, minus, so now 8 to the 5/3, you could just simplify 8 down to 2 to the 3rd. Sure. It would be 2 to the 3rd to the 5/3, or times 5/3, and then the 3's, since it's 3 over 1, would cancel out, and it would just leave you to 2 to the 5th. 2 to the 5th is equal to 32. So it would be 96 minus 3 over 5 times 32. All that. Or no. The 0, you don't have to add the 0, because if you just plug 0 in, that would just equal 0 the whole time. And then, so that can get simplified down more. The 32 times 3 over 5 is equal to 96 over 5. And you want to simplify that 96, or put it into a fraction form. So 96 times 5 is equal to 480 divided by 5 minus 96 over 5. So then 480 minus 96 is 384 over 5, and that's times pi, so it's just going to be 384 pi divided by 5. And that is your final answer.